So we're having this panel on theory versus design approaches for behavior change research. And it is looking at the tensions of how to design applications, interactions, interventions where you want to change people's behavior for more positive health outcomes. We know user-centered design practices really well at Georgia Tech. We teach that every day. And the question for us is, how do we learn from the theory of health behavior change literature, and how do we integrate that into our designs, especially when the theory might be telling us one thing and user-centered design could be telling us something different. So we want to design applications that encourage people to be healthy, to be active, to be running, to be out doing things. We actually want to design interactions that get people away from the computer. So how do you have this tension of you design an engaging interaction that leads people to do things away from the computer interface?
Behind me, this is a poster for a project called the DBBT. That stands for Digital Box and Block Test. So traditionally, for stroke rehab, the physical therapists, they do this box and block test. Calculate how many blocks can you move from one side to the other side. So this is very tedious. Somebody have to be there and calculating, measuring how long you take. The innovation we have here is that we put a simple Kinect. So we can detect automatically how many blocks you're moving, but we also give you more information. Now we know your fingers. Are you crouching your finger? Are you moving? Or are you just taking something in your palm and moving your shoulder? So now we're giving the physical therapists a lot more information about the progress. So all the therapists are very happy about this because this is beyond their traditional practice.
The title of our paper is "A Text Message a Day Keeps the Pulmonologist Away." And it's a paper where we replicated a set of findings where kids that responded to a text message about asthma knowledge and their asthma symptoms were actually more likely to have improved lung function after 3.5 months of texting daily. Going into the study, our hypothesis was that if we could make kids aware of their symptoms, that they would actually pay attention to their medication. And we did get some of that feedback during the interviews. They did say, look, sometimes I'd forget to take my meds and then I get my text and I'd be like, oh, I better take it. Or in some kids were actually proactively set up their texts at the same time as their meds so that they would be linked together. So we've got this to replicate. So does this actually transfer to other diseases? And then we want to ask, well, does it work with adults? Is it just that texts are the perfect technology for this population? In a day and era where there's so many sensors, that really simple technology can give us really important results.